Our micro-optical components are highly sensitive and need proper packaging. If you want to learn how we do it, especially for prototypes, just stick around and we'll check it out. So today we are talking about vacuum forming. It's a thermal forming method for sheet plastic, and what you can see here is the actual blister we're using in our production. It's produced in high volumes on automated machines. But this is the end of the path, because the beginning can be a little bit more complicated. At first we're talking about prototypes, and as these machines need milled aluminum molds, this can be quite expensive. And each prototype looks different, and the same applies to the blister itself. So what is the solution to this point? For us, the enabling factor is 3D printing. Because if we're using a high temperature material, it's quite easy to produce molds and test them. The first step is mechanical design in CAD. So we are designing this mold, and then it is printed out, and here this is a printed mold we are using. And of course there are certain design rules, meaning the depth of such cavities must not be too deep. You have to avoid sharp edges, because the material can be harmed during this process, so we apply a radii, and of course you need draft angles to get the mold out of the piece. What you can see here in the bottom of the cavities, we applied some vacuum holes, and at this point I want to explain a little bit more on this vacuum forming process. We have a more or less perforated base, there's vacuum underneath, and we place this mold on top of this plate, and then we have a plastic sheet. This is in a frame, and it's heated up so it gets soft, and when it has the right degree of softness, it's pushed down and the vacuum sucks it inside these cavities. And like that, when it's cooled down, you have the blister you are looking for. To show you how we are doing it in-house, this is our tabletop machine, so it's not capable to do tens of thousands of pieces for a series production, but it's perfect to do some prototypes or even do some hundreds of them. It's working like I explained it, so you need to take this raw material, this sheet plastic, place it inside this frame. Then the frame is locked. And after locking the frame, we can push it up. And here at the top there are heating elements. This means the material now is heated up, so it's getting softer and softer. While this is heated up, I can take the mold, place it here on this base plate. As mentioned before, there are lots of holes, so the vacuum pump, which is inside the machine, can work and put its strength to this plastic. Now you can place the question, or you could ask, why are you using these blisters? Because cardboard material is better for the environment, and it's quite typical nowadays. The answer is quite easy. On the one hand, cardboard would be good or would be relatively good for ESD reasons, but the main point is if our components are assembled to optical elements, for example to silicon photonics chip, then any particles can be a big problem. And perhaps you remember we did a video on this point where you could see how many particles can be generated by paper and cardboard. So as you can see here, the material is getting softer and softer. We need some more degrees of temperature, but yeah, no problem. So now we can push down the material, and as you can see, it's sucked immediately down to the cavities of this mold. And after several seconds of cool down time, so the material has to become hard again, we can open the frame and we can release our blister. Of course, we have to cut it to the right size, but this is our way to do prototype moldings or to do such blisters and to check if the design is okay for our processes. So I hope you learned something today. If so, please leave a comment, subscribe and like the video, and see you in one of the next videos. Bye bye.